Okay, in tonight's lecture, we're going to do a quick review of rounding. I'm going to teach you just a quick review on counting significant digits. Things that I will teach you that are new today are significant digits in simple calculations, but also significant digits in calculations that have intermediate steps. You are probably going to need a calculator for this lesson, and you'll definitely be wanting to take your Cornell notes. So here's an introduction. So let's say that you and a partner are measuring a piece of yarn that's exactly 1 foot long by definition, and you use a ruler and you take 5 successive measurements, and let's say measurement 1, 12.4 inches, 12.2 inches for measurement 2, 12 inches for 3, 11.8 for 4, and 11.6 for 5. So if the goal is to figure out what the accuracy and precision of each data set is, you can sort of think about accuracy as an average measurement. So if you average up all these numbers, 12.4, 12.2, 12, 11.8, and 11.6, you will find that they actually average out to 12. 12 is right there in the middle. So that means that this number, since it averages to 12, it's actually pretty accurate. Now, in terms of precision, it's not so very precise up here, because in order for something to be precise, the numbers have to be really close to each other, and these numbers are actually pretty far apart. So I'm going to say not precise. So accurate, not precise. Now down here we can apply the same rules. 11.5, 11.5, 11.6, 11.5, 11.6. Those numbers are really close together, so we're going to call those precise. But they're not averaging out to be 12. So I'm going to call those numbers precise, but not accurate. Okay. This is a review. We're going to use yesterday's rule to round each of the following numbers to the indicated decimal place. So that means I'm going to be rounding to this digit, which of course means I need to actually be looking at that digit. So after the rounding, I'm going to get 410.98, and that 7 that I'm looking at is actually going to go up to an 8 because of the 7 that follows. Over here, I'm going to round to this digit. I really need to be looking at that digit to make the rounding. So my final answer is going to be 8.0. Over here, I'm looking at this number. The 5 would go up to a 6 if this digit were 5 or higher. So it's less than 5. So I'm going to leave that a 5, and I'm going to put some zeros right here to hold places. Down here, I'm looking at this 9. I want to check out this 9 right here. Since this is above 5, it's actually going to push this digit up to a 10, which I'll put a 0 here and I'll carry a 1 and make that a 6. And my last one on this slide, take a look at this digit, the 5. We're going to leave it a 5 because that digit's a 3. And I will write 0.05. A review on counting significant digits. I actually, at this point in the game, would recommend using the Atlantic-Pacific rule because it's really easy to remember, even if it ignores the traditional methods. Remember that if you have a decimal point which is present, like in this number, the P in present goes with the P in Pacific. So that means that you're going to be counting from the left-hand side of the number to start with, and you'll start with the first non-zero digit and count until the end. So in the case of this first digit, this first number, the 2, the 3, the 4, the 5, and the 0 are all going to count because we're starting at the 2 and going all the way to the end. Since it's like present, the decimal point's present, so we're going to the Pacific side over here and counting on our way in. So I see 5 digits. For the one below that, decimal point is present, so you start counting from the Pacific side of the number, and you skip the zeros and you go to the 8. So the digits that I see that count are the 8, the 7, and the 3, or 3 digits. If the decimal point's absent, like in this number, then you start on the Atlantic side, which is over here, with the first non-zero digit. That's actually this 2, and I'll count until the end. So that's really all of the digits. So that is 6 digits. And the next one, decimal point's present, so start from the Pacific side with this digit, the 5, and count until the end. So I just counted 4 digits. And then lastly, 501, we have Atlantic, or absent, so Atlantic, and start counting with that 1 and go to the end. So I'm getting the 1, the 0, and the 5, all of them, so 3 significant digits. Now, this slide is going to have some new stuff on it. We're going to do some very simple calculations, and in those calculations, we will apply what we know about significant digits. You will need a calculator for this part. I'll pause the video for a second, and you can find a calculator. All right, so when you do these calculations and you're going to be using significant digits, the very first thing you should really be thinking about is whether the operation you're doing is multiplication and division, or whether it's addition and subtraction. Totally matters. Let's say that you're doing multiplication and division, then the measurement with the fewest significant digits is actually going to determine how many digits are allowed in the final answer. So, what I'm basically saying here is in the number, for instance, 3.052, I am counting 4 significant figures. In 2.10, I see 3. And in 0.75, I see only 2 sig figs. That means that the number of all of those 3 that has the fewest significant digits is this one, which is 2. So it has 2 significant digits. It's that one right there. And when I get my final answer in a moment, I'm going to restrict my answer to having only 2 significant digits, just like 0.75 has. So in this line right here, I'm really just looking for you to just do a raw answer. So just multiply those 3 numbers together. I got 4.8069. But I'm only going to keep some of those digits because if you look up here, I should really only be keeping 2. So I'm going to keep the 4 and the 8, and my final answer will be 4.8. Do note that the units matter in multiplication and division. So this meter times this meter, multiplied again by that meter, meter times meter times meter, you're going to be getting meters cubed. Now when you do addition and subtraction, I'm actually going to not really think that much about significant digits. I'm going to think a lot more about the number of decimal places each of these guys has, because the rule here is that the measurement with the fewest decimal places determines how many digits are allowed in the final answer. So for instance, I have 1 decimal place, 0, 3, and 2. That means this guy with 0 decimal places is going to be the one that influences the answer the most. Go ahead and add those numbers together now, and then we'll talk about the decimals. I'm getting a pretty large number. I'm getting 2, 5, 4, 0.091. But I don't get to keep all those decimal places because this one right here only has, well, it has 0 decimals. So I'm going to keep 0 of these decimals. I'll knock all of those out. And my final answer is 2, 5, 4, and 0. So so just quickly on this review on this slide, multiplication, division, you count sig figs, and whoever has the fewest, that determines how many are in the answer. For addition and subtraction, you don't count sig figs, you count decimal places, but whoever has the fewest decimal places, that'll determine how many decimal places the answer has. So like in this guy right here, 0 decimal places, that means I should only have 0 decimal places in my answer. If you have intermediate steps, here's my advice. Calculations that involve intermediate steps should not have their numbers rounded off to significant digits until the final answer has been reached. So basically, don't do any significant digit stuff until you've gotten to the final answer. This guy has an addition, but it also has a division. So we're going to use 2 different sets of rules. Let's go ahead and do the 35.6 and the 2.4 now. So you'll need to add those 2 numbers together. You can pause while you do that. I'm getting 38 even. I even double checked just to make sure. So I got 38 even, that's liters. And then over 4.803, that doesn't have a unit. But when I do a division versus when I do an addition, my rules are a little bit different. So let's go ahead and, since I did that addition first, let me just check my decimal places to see if I did it right. So this number has 1 decimal place and this number has 1. And then my answer has none, and they should really match up. So I'm going to go and I'm going to put a 0.0 because I want to have the same number of decimals, or no fewer, no less. So when I go down here to do the division, I have a number that has 3 significant figures and another number that has 4. So I'm just going to go ahead and do that division now. I'm going to do 38.0 divided by 4.803, and I'm getting like 7.911. I'll even put another 7 in there because it does keep going. But I should really only be keeping 3 sig figs because the 3, the 8, and the 0 is only 3. I'm going to keep those 3 then. So I'm getting 7.91, and my unit would still be liters. So I did my rounding only in the last step. So you round only in the last step. You can do significant figures and stuff in between, but you round only in the last step. So I'll do one more example here. This part looks like it needs to be done first because it's in parentheses, and it is subtraction. So this guy who has only 2 decimals, that's how many decimals my my very first answer is going to have. So I'll go ahead and do that subtraction, and it says 16.408 minus 3.88. I'm getting 12.9 12.528. Meters. I'm only going to get to keep 2 decimal places, so I will go up to that 5.2 there. Now, it does say that when you're doing these calculations involving intermediate steps, that you do not round off to the significant digits until the final answer has been reached. So I'm going to leave this as 0.528, and I'll just keep track that I need to be rounding off to at this 2 at some point. So using the whole number, 12.528, multiplied by 2.542. And my entire answer is coming out to be 31.846176. Maybe it goes on and on like that, but that's all my calculator is showing. It's going to be meters squared. And this guy had a total of 4 sig figs after rounding. This one also has 4 sig figs, and so this is multiplication. I'm going to only get to keep 4 in my answer. It's going to be those. So I'm going to settle on 31.85 square meters. Okay, at this point, I think that you are pretty much done with your Cornell notes for this lecture, but copy down this little data table. It's actually an excerpt from the reference table. And also copy down this question. It says a brick used in the construction of pottery kilns is 11.0 centimeters wide, 6 centimeters tall, and 22.7 centimeters long. The brick has a mass of 2950. What's the density of the brick? So copy down this question, and we'll work on it in class tomorrow. And I'll also ask you to copy down anything from the summary right here. So copy down these questions, and we'll work on these in class tomorrow as well.